Now in this question we are given that groceries are in a bag with paper handles that you can see in this figure. Now the two handles together will tear off if the force is greater than 51.5 Newton. So if the force which is greater than this value is applied, then the handles will tear off. Now we need to find what is the greatest mass of groceries that can be lifted safely with this bag, given that in the A part we have to consider that you are raising the bag with constant speed and you are raising with an acceleration of 1.25 meters per second squared. Okay, so this question is an application of Newton's second law of motion. So we're going to solve the A part first. Let the mass for the groceries be m. Now we can draw the free body diagram. So your hand will apply the force on the upward direction on the paper handles. So let this be F, and the groceries gravity force would be acting in the downward direction. So this would be mg. Now in the A part it moves with a constant speed. That means acceleration is 0 in the vertical direction. So by using the Newton's second law of motion, we can write that F minus mg, this is the net force, and that is equals to 0 because there is no acceleration. And from here this F will be equals to mg. Now from here we need to find mass. So mass would be equals to F over g. So maximum force that it can handle is 51.5 Newton, and g value is standard 9.81 meter per second squared. So from here you'll get the mass to be equals to 5.25 kgs. So maximum mass that you can put in the bag is 5.25 kgs. Now next in the B part it says now you raise the bag with an acceleration of 1.25 meter per second square. So this time if you draw the free body diagram, this is mg here, force F here, and we have an acceleration in the upward direction to be equals to 1.75 meter per second squared. Now if you apply the Newton's second law of motion, we can write that net force is mass times acceleration. Net force we have F minus mg, m times a we can write. Now our aim is to find the mass. So rearranging the terms, we can write F is equals to ma plus mg. M you can take common, so a plus g. So from here the expression for mass will be equals to F over a plus g. Now we can put the values. So m is equals to force we are given in the question to be 51.5. This is the maximum force that can be applied. 51.5 Newton divided by a is given in the equation to be 1.25 plus g is 9.81 and the unit is meter per second squared. On solving you will get the mass to be equals to 4.66 kgs. So the maximum mass that you can put in the bag is 4.66 kgs. Now in this question we are given that at the airport you are observing some of the jets. Now you observe that it takes about 35 seconds for the jet to go from rest to takeoff speed, and also you estimate that the distance required is about 1.5 kilometers, and the mass for the jet is 1.7 times 10 to the power 5 kgs. Now our aim is to calculate the force needed for the takeoff, and in the B part we need to describe the strategy that we used to solve the part A. Okay, so first I'll go into solve the part A. Now here it is given that the distance required for the takeoff is 1.5 kilometer. So delta x we have 1.5 kilometer. This direction I'm taking positive x, and time it took for the takeoff is 35 seconds. Now first we will be calculating the acceleration, then only we can find the force. So to calculate the acceleration we can use the kinematic equations that we studied in the previous chapters. So delta x we can write v naught t plus 1 over 2 at square, and initial speed is 0, so this term goes to 0. So from here acceleration would be equals to delta x times 2 divided by t square. Now from here 2 times delta x, we have 1.5 kilometer. We can convert the unit into meter, so multiplied with 1000, this much of meters, divided by time is 35 seconds, so it's whole square. So from here you'll get the acceleration to be equals to 2.45 meter per second squared. So this is the acceleration. Now we can make the free body diagram if you like. So this is the mass of the aircraft, this is the force, and the acceleration we have 2.45 meter per second squared. So by using the Newton's second law of motion, we can write force is equals to mass times acceleration. Mass is 1.70 times 10 to the power 5 kg, and acceleration we have 2.45 meter per second squared. So from here you'll get the force to be equals to 4.2 times 10 to the power 5 kg. So this is the answer for the A part. Now next, in the B part, we have to define the strategy that we use to solve part A. So first we calculated the acceleration by using the kinematic equations, and then by using the Newton's second law of motion, we calculated the force. So this would be the answer for the B part. Now in this question we are given that we have two boxes, box 1, box 2, with masses m1 and m2 respectively, and they rest on a smooth horizontal surface. Now the box are in contact with one another, that you can see here. If the box 1 is pushed with force F of magnitude 12 Newton, then the contact force between the boxes is 8.50 Newton. Now next it says, if we apply the force on the box 2, then the contact force is 3.5 Newton, and in both the cases the boxes move with an acceleration of 1.70 meter per second squared, and our aim is to calculate the mass of the two boxes. Okay, so we're going to assume that we are applying the force on the box 1, and we're going to make the free body diagram. So this is the box 1, m1, and we are applying force in this direction with magnitude 12.00 Newton, and the contact force is 8.50 Newton. So this would be the direction for the contact force on the m1 box. This is force on 1 due to 2. Now we can write by Newton's second law of motion. And one more thing, acceleration we have given to be 1.70 meter per second squared, and this F2 is 8.50 Newton. Now by using the Newton's second law of motion, we can write that net forces is equals to mass times acceleration. So here we have net force F minus F12 is equals to m times A, and this m is m1. Now rearranging the terms, we can write m1 will be equals to F minus F12 divided by A. F is 12, F12 is 8.50, A is 1.70, and if you solve this, you'll get the mass for the box 1 to be 2.06 kgs. So this is the answer for the A part. Now next we're going to find the mass for box 2. So again we can make the free body diagram for the mass 2 this time. So this is m2 here, and this time also I'm assuming that you're applying the forces on the box 1. So if you apply the force on box 1, the contact force we have F12 is 8.50. This is the contact force on body 1. By using the Newton's third law of motion, the same contact force will be applied on m2 mass from the m1 mass, but in the opposite direction. So this would be the direction of force on 2 due to 1, and acceleration we have 1.70 meter per second. Now by using the Newton's second law of motion, we can write m2 will be equals to F21 divided by A. F21 is 8.50. This is the magnitude would remain same, just direction is changed. Acceleration is 1.70. From here m2 comes out to be as 5.00 kgs. So this is the answer for the B part. In this question it says that you and some of your friends take a hot air balloon ride that you can see here. Now one of your friend is late and the balloon floats a couple of feet off the ground as you wait. Now before this person arrives, the combined weight of the basket and the people is 1220 kgs and the balloon contains 5980 kgs of hot air and is neutrally buoyant. So what the question is saying, when your friend is late, the balloon already floats a couple of feet off the ground and it moves with the constant speed because it is neutrally buoyant, it says. So if we draw the free body diagram, the buoyancy force will be acting in the upward direction and the gravity force, this is the total mass of the balloon times g, this would be acting in the downward direction. Now it says it is neutrally buoyant, that means the buoyancy force will be equals to the gravity force, right? And total mass mt, we have this 1220 kg plus the mass of the hot air, which is 5980 kgs, which is equals to 7200 kg. Now next it says, when your friend arrives, he climbs up into the basket and the balloon begins to accelerate downward with this much of acceleration. And our aim is to calculate the mass of the person who came late. So let the mass of the person who came late be mp, and this is what we have to find. Now I'll be drawing the free body diagram for the balloon when the balloon started accelerating downward with this much of acceleration. So this is our balloon and the buoyancy force still acts in the upward direction fb, right? Now when this person catches the basket, the gravity force that would be acting on the balloon would be mt plus the mass of person times g, and due to this the balloon accelerating downward with acceleration 0.10 meter per second squared. Now simply by using the Newton's second law of motion, we can write that F net is equals to mass times acceleration. This direction I am taking positive, so we can write that mt plus mp, this is the gravity force, minus fb, this is equals to mass times acceleration, and mass will be total mass plus the mass of person times acceleration. Now fb we already calculated to be this value, so we can put it here, mt plus mp times g minus mt times g is equals to mt plus mp times a. Now from here we can find the expression for the mass of person. So do one thing, divide by this term in the left and the right side of the equation. So this would become g minus mt divided by mt plus mp times g is equals to, this would become a, right? Now from here we can take this term to the left side, so g minus a is equals to mt divided by mt plus mp times g, and from here we can write mt divided by mt plus mp is equals to g minus a divided by g, which is equals to 1 minus a over g. Now we have all the values, we have the values for mt, we have the values for a and g, we know. We can easily calculate mp from here, just put the values. So mt we have 7200 kgs, 7200 kgs. Mass for the person we need to find is equals to 1 minus a is 0.10 and g is 9.81, right? Now rearranging the terms, we can write that 7200 kgs is equals to, this would become 0.989 times 7200 kgs plus mp, and from here you'll get the mass for the person to be equals to 74.21 kgs. So this would be the required answer for this question. Now here in this question we are given that when two people push in same direction on an object of mass m, they cause an acceleration of magnitude a1. So let's picturize this problem. So here this is object with mass m. Now two objects apply force in the same direction. So in this direction two people are applying forces. Let this force be Fa, let this force be Fb. And due to this mass is accelerated with magnitude a1. Now next, in the second case, it says if the same people apply the force in the opposite direction, then the acceleration of the object has magnitude a2. So this is mass m. So this time the force applied by the a person is in this direction Fa, and the second person apply the force in this direction Fb, and let the acceleration be a2 as per the question. Now our aim is to calculate the magnitude of the force exerted by each of the two people in terms of m, a1 and a2. Okay, so simply we can use the Newton's second law of motion here, and by using the Newton's second law we can write net forces we have mass times acceleration. So for the case 1 we can write that Fa plus Fb, this is the net force, which will be equals to m times a1. And for the second case we can write that Fa minus Fb, because Fb is along the negative direction, this direction I have taken positive, that is equals to m times a2. Right, let this be equation number 1, let this be equation number 2. Now just add equation 1 and 2. So if you add this Fa and this Fa would become 2 times Fa, and this plus Fb and this minus Fb will cancel, and you'll get this is equals to m times a1 plus m times a2. From here we can write that Fa will be equals to m, we can take common, a1 plus a2, and this 2 will come here. So this would be the force Fa. Now to calculate the force Fa, just put the value of a here. So you'll get m over 2 times a1 plus a2 minus Fb is equals to m times a2. Right, rearranging the terms we can write m over 2 a1, then plus m over 2 a2. This time I'm taking to the right side, sorry, left side, so m times a2 is equals to Fb. This would become m over 2 a1, and this would become minus m over 2 a2 is equals to Fb. Take m over 2 common from here, so here I will get a1 minus a2. So this would be the expression for the force B.